Welcome to Talk Treatises.
Great to be back.
We spend a lot of time on this show parsing the grand sweeping narratives of history, the rise and fall of empires, or, the fiery manifestos that launch revolutions.
The big picture stuff.
Exactly. But today, we're doing something a little different. We are looking at the architecture of thought itself. We are looking at a book that takes something we all feel, that gut instinct about luck, chance, and certainty, and tries to pin it down with the cold, hard nails of logic.
That's a great way to frame it. We are diving into the third edition of The Logic of Chance, written by the Cambridge logician John Venn.
John Venn. Okay, so everyone listening is probably picturing a diagram right now.
The overlapping circles, of course. We all drew them in grade school. But his contribution to the philosophy of probability is, I would argue, far more radical and, frankly, far more disturbing to our comfortable view of the world than some circles on a page.
And just to set the stage here, we aren't talking about a modern textbook. This work, it's sort of hit its stride in the mid to late 19th century. We were talking about the 1860s through the 1880s.
Right.
This is a time when the world was obsessed with measurement, isn't it?
Oh, completely. This was the era where mathematics was beginning to encroach really aggressively on the domain of philosophy. You have to understand the prevailing mood.
What was that like?
Well, the Industrial Revolution is roaring. Darwin has just published On the Origin of Species a few years earlier. And there is this sense that if you can just measure something precisely enough, you can master it.
Anything can be quantified.
Anything. But in the world of probability, the dominant view, and this was championed by intellectual giants like Augustus de Morgan and Marquis de Laplace, was what we call the conceptualist view.
Okay, let's unpack this immediately because conceptualism sounds a bit abstract. What were they actually arguing regarding how we perceive the future?
They argued that probability is a measure of the quantity of belief.
The quantity of belief.
Yes. It is fundamentally psychological. If I say there is a 50% chance of rain, under the conceptualist view, I am describing a state of my own mind.
So I'm not describing the weather.
No, you're describing your brain. You're half certain. Ideally, certainty is a 1, impossibility is a 0, probability is everything in between. It is about you, the thinker, and your lack of perfect knowledge.
Right. So if I flip a coin, the 50-50 isn't a property of the coin. It's just a fancy way of admitting, I don't know what's going to happen.
Exactly. If you knew everything, the wind speed, the force of your thumb, the air resistance, the exact weight distribution of the coin, you wouldn't say 50%.
Would you say heads?
You'd say heads. So probability for them is just a crutch for ignorance. But then comes John Venn. And Venn looks at this belief model and essentially says, this is scientific nonsense.
Strong words.
Very strong. He introduces what he calls the material view of logic. And he argues that logic and probability, they don't deal with thoughts. They deal with things.
With things in the world.
Yes, with facts in the external world.
And this is the core problem, isn't it? The hook of the whole treatise. Venn poses this question. If you say there is a 50% chance of rain, are you describing your own ignorance, or are you describing the clouds?
And his answer is emphatically, you are describing the clouds. Or, more accurately, you are describing the statistical history of the clouds.
Okay.
Venn's central thesis is that probability is not a science of partial belief. You cannot measure a feeling. It's a science of statistical frequency based on a series of events.
That word series, it comes up constantly in the text. I mean, it seems to be the absolute anchor for his entire worldview. Why is he so obsessed with it?
Because it is the foundation of the material view. And here's where it gets really interesting and perhaps a bit unsettling for anyone listening who likes to think of themselves as a unique individual.
I'm intrigued.
Venn insists, absolutely insists, that probability cannot exist for a single isolated event.
Wait, hold on. I want to push back on that because that feels deeply counterintuitive. If I ask, what is the probability of this specific coin flip coming up heads right now?
Yes.
Venn says that question is meaningless.
In isolation, yes.
Yeah.
Utterly meaningless. Probability only comes into existence when that coin flip is viewed as one term in an infinite or at least a very, very large series of flips.
So you can't talk about the one, you can only talk about the many.
That's it. He uses the John Smith analogy to drive this home, which I found fascinating, but also...
kind of cold.
Yes, exactly. Kind of cold.
So let's walk through that for everyone.
It is the classic actuarial problem. Suppose you have a man named John Smith. He is 30 years old, he has a slight cough, he lives in London, and you, as an insurer or a doctor, want to know, will John Smith die this year?
Right. And a conceptualist, or really any of us in a normal conversation, would say, well, I believe he has a low chance of dying, maybe 1 in 50 or whatever the number is. We'd assign a belief to it.
But Venn asks, where do you get that number? From where does that fraction emerge? You can't find it in John Smith's physiology. You can't perform an autopsy on a living man and find 150th of death inside his lungs.
No, of course not.
The event, for John Smith, is binary. It is yes or no. He will either die or he won't. The probability only emerges when you step back and you stop looking at John Smith.
And you look at what instead?
You look at a class of men, say 10,000 men aged 30 living in London. And in that group, you observe a certain frequency of death.
So we can say 1 in 50 men of this class will die, but we can't say John Smith has a 150th fraction of death hovering over him.
Precisely. The fraction belongs to the group, not the man. The probability is a property of the series, not the individual unit within it.
And this leads Venn to a very profound point about the average man.
Oh, yes. The average man is a complete fiction.
We talk about it all the time, though. Average life expectancy, average income.
Of course. But Venn reminds us that the average man does not exist. No one is perfectly average. It's a logical construct, a fictional entity we create to make the math work.
Statistical ghost.
A statistical ghost. He quotes that line of Tennyson, "So careful of the type she seems, so careless of the single life." Nature, or logic in this case, cares about the type, the series. The series is stable and predictable. The single life is chaotic and, in a logical sense, unknowable.
It's almost like he's saying the individual doesn't exist in the eyes of logic. Logic can only see the crowd.
It can only see the crowd.
That feels incredibly modern, actually.
Yeah.
It feels like how an algorithm sees us.
It is exactly how an algorithm sees us. And this is why he attacks the subjective or conceptualist view so hard. He critiques introspection as a scientific tool.
What do you mean?
He says, look, if you want to know if a chemical mixture is explosive, you don't sit in your armchair and look inside your mind and try to measure your feelings about it.
Right, you go to the lab.
You go to the lab and you blow things up. You test it against reality. You need external verification.
And probability is the same for him.
It's exactly the same. The only valid test is experience reality. If your degree of belief that a coin will land heads is very strong, maybe you have a lucky feeling about it.
Sure.
But the actual series of throws shows it landing heads only 10% of the time. Your belief isn't subjectively true. It is just wrong. Reality is the benchmark, always.
He talks about this scale of belief that the conceptualists love, this idea that our minds have an infinite gradation of belief, like a thermometer of certainty.
Right.
I have to admit, I kind of like that image. I feel pretty sure about some things and very sure about others. It feels true to experience.
Venn acknowledges we have those emotions. He's not denying the psychology.
Yeah.
But he asks, can you measure them? Can you truly quantify them?
What, like with a number?
Yes. If I ask you to quantify the difference between your belief that the train will be late and your belief that it will rain tomorrow, can you give me a specific fraction? Can you say, I am 43.5% sure of the rain, but 62.1% sure about the train?
No, it would be completely arbitrary. I'd be making it up.
Exactly. But if we toss a penny, we don't half believe it will be heads. We anticipate a series where heads appear 50% of the time. The fraction belongs to the events, not the brain. The precision comes from the world, not our heads.
Okay, so if probability relies entirely on this series, this long run of events, we have to talk about what generates that series. We have to talk about randomness.
Randomness. This is one of the trickiest concepts in the book, and I think Venn handles it with such nuance.
Because he has a very specific definition. He doesn't just mean chaos, does he? It's not just a messy room.
No, not at all. For Venn, randomness is a specific kind of arrangement. It is an arrangement where, in the long run, every possibility is represented equally. It is the ultimate democratizer.
It's orderly chaos.
It's orderly chaos. And this brings up that paradox he mentions, that randomness eventually creates uniformity.
Which sounds like a total contradiction.
It's the great irony of statistics. If you have pure chaos, pure randomness, and you let it run long enough, it stops looking like chaos. It starts looking like a perfect, predictable pattern.
How does that work?
Think of throwing dice. One throw is chaos. 2 throws, chaos. But throw them 1,000,000 times and the distribution of results will form a beautiful, perfect bell curve. This is what mathematicians call the law of error, or the normal distribution.
The bell curve.
The bell curve. The chaos of the individual event completely disappears into the perfect uniformity of the average. The series tames the single case.
He uses some great examples from the real world to test this idea. He brings up the digits of pi.
Yes, he asks, are the digits of pi random? 3.14159, and so on.
Well, they're fixed, aren't they? They are mathematically determined. If you calculate them 1,000 times, they're always the same sequence. They're the opposite of random.
They are strictly determined, yes. But Venn points out that if you look at them as a series, they behave as if they were random.
What does that mean, they behave randomly?
It means that if you take a long enough string of them, every digit from 0 to 9 appears with roughly the same frequency.
Oh, I see.
He meets that in a short run, say the first 700 digits. The number 7 might appear less frequently than the number 9. A short run looks messy and uneven. But if you take 1 billion digits, the frequency of every number from 0 to 9 will settle out to be almost exactly 10%.
Wow.
The rigid, determined math produces a series that is, for all practical purposes, indistinguishable from pure chance.
So randomness isn't about the origin of the thing, it's about the arrangement of the series.
That is the crucial insight. And then he flips this logic to look at the stars. This is a beautiful image to me. He talks about the Pleiades.
The cluster of stars, the 7 sisters.
Right.
Yeah.
He asks, is the arrangement of stars in the sky random? I mean, if you took a bucket of white paint and just splashed it on a black ceiling, you would get a random distribution.
Right. Most of the ceiling would have nothing, and you'd have dots scattered everywhere.
But when we look at the Pleiades, that tight little cluster of 6 or 7 visible stars, Venn argues that the odds of them being that close together by pure chance are astronomically low.
It's too neat.
It's too neat. It's a deviation from the random series. Therefore, we infer design, or more accurately, causation. They are physically connected. They are a gravitationally bound cluster. They aren't just scattered. They are grouped for a reason.
So randomness has a limit. You can tell when something isn't random because it clumps together too much or forms a pattern that the series wouldn't predict.
Exactly. But Venn is careful to point out the difficulty of achieving pure randomness in the real world. He has this wonderful little example of trying to draw a random line on a piece of paper.
You can't really do it.
You can't. Your hand has a bias to move in a certain way. The paper has edges which constrain you. Even a random walk is constrained by the laws of physics. Pure randomness is a mathematical ideal that nature struggles to emulate perfectly.
Okay, this is a perfect transition. This leads us to what I felt was the engine room of the book, the distinction between induction and probability. I feel like in casual conversation, we use these words almost interchangeably. We say, it's probable that, or I induce that, meaning roughly the same thing. But Venn draws a very hard line between them.
A very hard line. And this distinction is critical for understanding his attack on the conceptualists, especially on Laplace.
So let's define them his way. What is induction?
For Venn, induction is the process of getting the rule. It is generalizing from the seen to the unseen. It's the scientific method, really. It is how we go from this fire burned me and that fire burned him to the general law, all fire burns.
It's detective work. You're figuring out how the world works.
Precisely. You're building the model.
Okay. And probability.
Probability is the process of using the rule once you have it. It is pure deduction. Once you have the statistics, once you know from observation that 1 in 50 men aged 30 die, probability is simply the arithmetic of applying that fraction to a specific case.
So induction is building the formula, and probability is plugging the numbers into the calculator.
That is a perfect analogy. And Venn thinks his rivals, particularly Laplace, got these two disastrously mixed up. This brings us to the famous rule of succession.
The sun-rising problem. Yes, this is one of the most famous problems in all of philosophy.
It is, and the argument as used by Laplace and others goes something like this. If an event has happened every times in a row, the chance of it happening again on the next trial is 1 + 1 meter + $2.
So if the sun has risen every day for, say, 5,000 years, which is a lot of days, you plug that huge number into the formula.
And it gives you near certainty, but not absolute 100% certainty that it will rise again tomorrow.
So Laplace tried to use probability math to prove the sun would rise.
He did. And Venn thinks this is utterly ridiculous. He argues that we don't assume the sun will rise because of a mathematical fraction. That's not why we're confident.
Why are we confident then, in his view?
We're confident because of induction, because we understand the cause. We have a physical model. We understand gravity, planetary motion, the rotation of the Earth. Our confidence comes from physics, not from just counting the sunrises.
He uses the flags on the ship example to tear this formula apart, and I think this really clarifies his point better than anything.
It is one of my favorite passages in the whole book. It's so clear.
Lay it out for us.
Okay. Imagine You are standing on a dock. You see a ship sail by, and it is flying a flag. Then a second ship sails by, also flying a flag. A third, a fourth. You see 10 ships pass, and all of them have flags.
Right. So the Laplace formula would say, I've seen it 10 times. So the probability of the 11th ship having a flag is 10 plus 1, 10 plus 2, or 11, 12. Very high odds.
And Venn says, that is absurd. The math is meaningless. Unless you know why the ships are carrying flags. Is it a national holiday? Is it a naval regulation that all ships of this type must fly one? Is it a fleet sailing together?
Without that context, the counting is useless.
It's worse than useless. It's misleading. The 11th ship could be a fishing boat. It could be a pirate. It could be from a different country. The mere repetition of the event means nothing without the inductive knowledge of the underlying cause.
He also mentions the shark and the pilotfish, a similar idea.
A very similar critique. If you see a shark and it has a pilotfish swimming next to it, just one, Laplace's rule suggests that because you've seen one instance, the odds are now 2 to 1 that the next shark you see will also have a pilotfish.
Which is just, it's silly.
It's silly. Venn points out that a single observation gives you no statistical series. You cannot build a probability on a sample size of one. It violates his most basic principle.
So what does this all mean for science? It means probability isn't magic. You can't just count things and expect to predict the future.
No. You need causation.
You need to understand the why.
Precisely. Probability requires a stable order of nature. We assume the future will resemble the past not because of the math of probability, but because of the law of causation, which we discover through induction. Probability rides on the back of induction. It cannot stand alone.
Okay, I want to move into the practical applications now, because Venn doesn't just stay in the clouds of logic. He talks about things like insurance and gambling.
Right, the real world.
And he has a very specific, almost moralistic take on how they differ.
He views them as complete opposites in terms of their relationship to uncertainty. He describes insurance as the diminishing of uncertainty.
Which makes sense. If I'm that John Smith we talked about, my life is filled with chaos. I don't know if I'll get sick, if I'll die and leave my family penniless. My future is uncertain.
Right. You are the single life, and the single life is volatile. But by pooling your risk with 10,000 other John Smiths, you can view the chaos of the individual into the certainty of the series.
The insurance company isn't gambling.
Not at all. They know with near-perfect statistical certainty how many people in that group will pay out. So you, the individual, buy certainty from them. You pay a small, certain cost your premium to avoid a large, uncertain cost.
You're eliminating risks from your life. And gambling.
Gambling is the exact opposite. It's the increase of uncertainty. You take a certain value, the money in your pocket, which has a fixed, known worth, and you voluntarily subject it to unnecessary chaos.
You're taking a fact, your cash, and turning it into a probability.
You're manufacturing risk for entertainment. Venn sees it as logically perverse.
He spends some time dismantling the martingale fallacy. I think every college student who goes to a casino for the first time thinks they've discovered this secret system.
I'll just keep doubling my bet.
Exactly. If I lose $5 on red, I'll bet 10. If I lose that, I'll bet 20. Eventually, red has to come up, and when it does, I'll make back all my losses plus a profit.
It seems so logical on paper. It feels foolproof.
So why does Venn say this fails every time?
He says it only works if you possess two things that no human has.
Which are?
Infinite time and infinite money.
Yes. That is a bit of a problem.
It's a huge problem. In the real world, you either hit the table limit imposed by the casino or you simply run out of cash. And when you do, the exponential growth of the loss 5, 10, 20, 40, 80, 160 wipes you out completely.
So it's not a strategy, it's a logical fallacy.
It's a fundamental misunderstanding of how the series works. You cannot force the series to regress to the mean on your timeline. The series takes its own sweet time, and it has deeper pockets than you do.
This brings us to a really fascinating section on truth. Can we calculate the probability that someone is telling the truth?
The witness problem. This is a hot topic in the 19th century, especially in legal theory. Mathematicians desperately wanted to quantify testimony.
And their method was to treat witnesses like
bags of balls.
Bags of balls! That sounds incredibly dehumanizing again.
It is the theme, isn't it? The logic can't see the person, only the statistic. So imagine a bag with 9 white balls and 1 black ball. You pull a ball. The chance of it being white is 90%.
Okay.
They tried to say. This witness, based on his past record, tells the truth 90% of the time. Therefore, he has a bag with 9 white balls, truths, and 1 black ball, a lie.
And if 2 witnesses agree, you just multiply the fractions. Like 910 times 910.
That was the hope, to create kind of mathematical calculus of belief. But Venn rejects this entirely. He argues that human veracity is not a fixed number. It isn't a series in the same way a coin toss is.
Why not?
Because it depends on the story being told.
Oh, absolutely. If I tell you I had eggs for breakfast, I'm probably telling the truth. If I tell you I saw a ghost this morning.
Exactly. Your credibility plummets. The probability of the witness lying is completely entangled with the inherent probability of the event being true. You cannot separate them.
So treating human being like a static truth generator with a fixed percentage is a fundamental error.
A category error, in Venn's view. It's applying the logic of chance to a domain where it doesn't fit.
Which leads naturally to the discussion of miracles. This is the ultimate test case. How do we weigh the improbability of a miracle against the improbability of a witness lying about it?
And Venn's answer is, well, we can't, not with simple math anyway, because we don't have a series of miracles to judge by. We can't say, oh, resurrections happen, 1% of the time. We have no data. We have a sample size of maybe 1. Or 0, depending on your view.
So we can't form the series.
We can't form the series. So when we weigh a miracle, we are off the map of strict probability logic, and we're back in the realm of induction, general evidence, and historical criticism. Math has to bow out.
We're getting toward the end of the text analysis here, and I want to touch on the high-level philosophy of the material world. Venn calls probability a transition stage. What does he mean by that?
Yes. He sees it as a bridge. We have a conception, a guess, a hypothesis, and we are waiting for reality, catch up, for it to turn into a fact. Probability is the waiting room between ignorance and knowledge.
And he makes this really cool point about the past and the future. To logic, they're exactly the same.
This is very counterintuitive for us. We feel like the past is fixed, it's fact, the future is fluid, it's chance.
Right, the past happened.
But Venn says, logically, if you have lost the records of a past event, if a library burns down and the only copy of a history book is destroyed, your guess about what was in that book is mathematically identical to a guess about the future.
Ignorance is ignorance regardless of which direction on the timeline it's in.
Precisely. Time is irrelevant to the logic of chance.
Finally, before we get to our thought experiments, we have to talk about chance versus design. The typo analogy.
Ah, yes. The Shakespeare argument. Could a monkey hitting keys at random on a typewriter produce the complete works of Shakespeare?
And what does Venn say? Mathematically, yes.
Mathematically, in an infinite time frame, yes. The series of random letters must eventually produce every possible combination, and that includes Hamlet, Macbeth, all of it.
Oh.
But, and this is a huge but, Venn argues that while it is mathematically possible, it is practically impossible. It is so improbable that it falls outside the realm of rational calculation or belief.
He distinguishes between the random draw and the poem. If you see a pile of letters drawn from a bag, you infer chance. If you see a poem, you infer design.
Yes. And it's not because chance couldn't have done it in a trillion years. It's because the odds are so staggeringly against it that design becomes the only rational inference.
It connects back to the Pleiades. Could the stars cluster that way by chance? Theoretically, yes. Is it rational to believe they did? No. You infer a cause.
Exactly.
Okay, that is the landscape of the logic of chance. It is a world of series, not individuals. A world of objective facts, not subjective feelings.
A material world governed by frequency.
Now, in true talk treatises fashion, we're going to take these 19th century ideas and push them off a cliff to see if they fly. It is time for our thought experiments.
And here comes the disclaimer. These are outlandish hypothetical scenarios inspired by the text. They are for entertainment and educational exploration only. We are not postulating new physical laws here.
Definitely not. Okay, experiment number 1. I'm calling this the demiurge's alphabet.
Ooh, I like it. Sounds very grand. Set it up.
So Venn talks about drawing letters from a bag to form words. Let's scale that up, way up.
Okay.
Imagine a creator, a demiurge, a sort of lesser god, who doesn't design the laws of physics. He doesn't sit down and decide gravity will be this strong or the speed of light will be this fast.
So he's not an architect, he's more of a gambler.
He's the ultimate gambler. Instead of drafting a blueprint, he has a cosmic bag of possibilities. This bag contains an infinite number of possible physical constants, infinite possible laws. And for each new universe, he just reaches in and draws a set at random.
So he is literally rolling the dice on the universe.
Exactly. He pulls out a set of laws.
Yeah.
The gravity constant is too strong, crunch. The universe immediately collapses into a black hole.
Okay, try again.
He draws again. This time, the weak nuclear force is too weak. Poof. Atoms can't form, and the universe is just a thin, useless soup of particles. But if he draws enough times, an infinite number of times,
he eventually draws the Goldilocks universe, the one with the constants just right for stars, planets, and life to form, the one we live in.
Right. So here's the twist, based on Venn's logic. If he is right, and probability only exists in a series, does that mean the series for our existence exists across a multiverse?
That is a staggering thought.
Yeah.
That for our single successful universe to exist as a probabilistic outcome, there must be an infinite series of failed, chaotic, dead universes alongside ours.
We are just the statistical outlier with a run of 100 heads in a row after trillions of tails.
Our existence becomes proof of the graveyard of other universes.
And if that's true, is there any difference between chance and design? If the demiurge rolls the dice enough times to produce a universe as intricate as ours, a Shakespearean universe, is that outcome distinguishable from a god who designed it on purpose from the start?
Well, from inside the universe, from our perspective, Venn might have to argue that you couldn't tell the difference. The result is what matters. But it really challenges his definition of design. Usually, design implies intent. Here, the result is perfect, but the process was random.
It implies that with enough chance, you can simulate God.
Which is either a terrifying or a beautiful thought, depending on how you look at it.
I think it's both. Okay, experiment number 2. I'm calling this one the civilization of short memory.
This plays on the past versus future idea, I take it.
Exactly. Imagine a civilization of intelligent beings that has a form of biological amnesia. Every 24 hours, their memories are wiped clean. They have no writing, no oral tradition that can survive the reset.
So they have no facts about the past, no history.
None whatsoever. To them, yesterday is just as opaque, just as unknown as tomorrow is to us. Now, in this society, they have 2 classes of revered experts. First, you have the prophets, who try to predict what will happen tomorrow.
Okay, like our futurists or meteorologists.
Right. And second, you have the historians, whose job is to retrodict what happened yesterday.
But without any records, the historians are just guessing too. They have no data to go on.
Exactly my point. Both groups have, let's say, 50% accuracy in their pronouncements. The prophet says it will rain tomorrow, and he's right half the time. The historian says it rained yesterday, and he's also right half the time.
Okay, I see where this is going.
Here's the twist. In this society, are the historians and the prophets treated exactly the same? Is there any logical distinction between their professions?
Under Venn's logic, they would have to be identical. There's no difference at all.
Right. They are both just dealing in probability. A guess about an unknown past event is the same as a guess about an unknown future event.
It implies that the only reason we treat history as fact and the future as probability is simply because we happen to have records, our memories, our books. If you remove the records, the arrow of time disappears logically. The past becomes just as much a matter of chance as the future.
Probability becomes the guide of life in both directions. You could imagine them having past insurance.
Past insurance? What would that even be?
I don't know. Maybe you pay a premium in case it turns out you accidentally committed a crime yesterday that you don't remember.
I'm paying a premium in case I did something stupid yesterday.
That's brilliant. It really shows how much our entire concept of chance relies on the simple crutch of memory.
Remove memory, and everything becomes a probability calculation.
That is a profound implication of the material view.
Wow. So after all this, what's the takeaway? We've unpacked the book, we've spun these wild scenarios. Where does it leave us?
It brings us back, I think, to the central point of the material view. Probability is out there in the world. It is a feature of reality. It is not just a feeling in your head.
And in our modern world, this is more relevant than ever. I mean, we live in the age of algorithms. Big data.
We absolutely do. And big data treats every single one of us exactly the way Venn described over a century ago.
To the algorithm, to the insurance company, the advertiser, the social media feed. You are not John Smith, the unique soul with hopes and dreams. You are a data point in a series. You are a user profile.
The John Smith problem is now the targeted ad problem.
Exactly. The algorithm predicts you will buy those shoes not because it knows you, not because it understands your aesthetic sense. It predicts it because it knows the series of people like you, people who have your browsing history, your age, your location. And it knows the statistical frequency with which that type of person buys those shoes.
We are all just members of a class.
We are in the eyes of the machine.
Which leaves us with a final provocative thought for everyone listening to mull over. If our most powerful tools for understanding the world's science, logic, data, can only understand us as part of a series, Does the individual actually exist in any meaningful scientific sense?
Or are we all just statistical artifacts, temporary deviations from a mean we are all eventually destined to regress to?
On that cheery note, thanks for listening to Talk Treatises.